Okay, so yeah, so just we were talking about like what happened last week. We were talking about K nearest neighbors.
Yep.
So it appears like we've squeezed the maximum out of this particular data set, unless we can think of
Yeah, yeah,
something else. So
yeah. We can check for as we said. We'll probably this is one thing I'm going to try as a general aspect as well is to see if we have other engineering data sets which we can use to see what we can do with data science. So I mean the thing with I was just writing a bit about some of my experience with these data for engineering systems, and one of the things that is very clear compared to whatever new technologies that are coming out, where they are using data science and machine learning a lot. One of the things is, in case of engineering systems, we have a very important advantage that using physical models, using differential equations, or even simple topological models, we have some understanding of the underlying system. So we can actually do some form of I would say interpretability better than just using what happens with other data sets. Use internet data where they just can do only correlation. They can't really do much of causation analysis there. I mean, they can do something, but but this is one thing we can probably uh, do as a kind of a series now, where we try to do some different data sets where, and then we can try and use do something with machine learning, and then see what can be a differentiation with respect to uh, whatever people use, because I see that a lot of technology that people use for machine learning and all that, recommendation systems, many of them are data which from internet, which they have a lot of data and all that, but you can do what I mean you don't know which way are the causality oriented, but we know in engineering systems. So perhaps we can, from the perspective of how to do it, we'll probably have to do more, and we'll continue to use Python and all that. That's how we can learn. I can also learn new things. But I think that we can, from now on, focus more and more on engineering data, perhaps multi-type data, multidisciplinary data, but at least engineering data would be a good idea, because I think all three of us are engineers and all three of us are electrical engineers in a way. So at least
Harish, are you an electrical engineer?
mechanical, right?
Ah, yeah, that's what I was thinking. Okay.
Yeah. Sorry. He's a robotics, some form of engineering, and in fact, you are more into power electronics and everything. I'm kind of nowhere, and he's a mechanical engineer. So in a way, we have some engineering backgrounds, and so perhaps that kind of thing would be useful for us, because I think in future, if we want to really do something using this, like as you said, doing something in terms of sort of machine learning for engineers kind of a course or something like that. I think for that, this kind of effort will be kind of useful. So Harish, I have a question. Do you know any data sets or anything that from your domain that you have?
Generally, we won't deal with much data. If we have the kind of feedback system, then we would have got that data. But like in general, we won't use much data because now I am dealing with the experimentation. I mean the pure mechanical. There is no uh, data which is coming from the system, and I can say that like in the next session, maybe I can come up with a geometrical data which can be analyzed as a cluster. So in previous session, I spoke about the data points which uh, suppose if we have a CAD model, so there is so much data on the surface. So generally we represent it with a triangular model, so where we have a preset data and vertices data, so which can be helpful maybe in this case. I mean, like we can analyze that way, that like finding the features maybe kind of helpful.
Okay. Yeah. Okay. Yeah, because I thought of this because I looked at this Python module called interpret and interpret.ml or something like that. And the funny thing was they said black box model and glass box model. I was like, what is this glass box model? So essentially, it's like linear models and things like those for which you can actually interpret what is happening, which is what from engineering perspective we know what the model is and we can work with them. So it was quite funny how the ML community is now kind of coming back to what is well known, but with their own term, because of course that's always an interesting way to portray it. So okay, then we'll probably go and hunt in Kaggle then, I guess.
Yeah, I think that's the only thing to do.
Yeah, I mean, I have done something before. There was a competition long back by Belkin on disaggregation, electrical disaggregation. So using the power meter data, how can you understand what are all the equipments consuming what power, when is it on, when is it off, etc. It's a very old challenge because we wanted to do it because we were working on that problem at that time, a few years back. I mean, before my PhD. But I mean, we couldn't come around to do it well because the data was huge and it was like a few GB at that time. And that time, few GBs were not a very good idea to easily work with. So now I guess we can probably even directly try in Kaggle's Jupyter notebook that they have. So we may not even have to download the data. So I don't know exactly how it works. So that kind of thing we can try, but also we can try other things. Do you know if any power electronics or power system related data that is available?
There might be. I'm not really sure. It's just that I don't really, there is not that much, like most of the stuff, the data sets which are there, at least with IEEE and things, those are like study data sets.
Yeah.
So that is not something that I think we can really use that much.
So in that case, I guess the competition data sets would perhaps be better, right?
Yeah, at least for learning, that is where we go. Now, I'm just thinking who could possibly be a source of data for the engineers. I don't really know.
Yeah. So, I mean, this problem that I have worked on, this non-intrusive load monitoring, where you have data from power meters in a household and sometimes data at appliance levels because they put some extra sensors there. So this NILM problem has a lot of data sets. I mean, just today, because I'm talking about this several times because today I realized that yesterday was the there is a online, I mean, there is a yearly conference that happens on this problem. Both industries and academia participates, and that was there yesterday. And I was seeing some parts of the conference live stream. I still have to see other things. So one way is I will just send a small link. I'll see where. So that link has a mechanism to actually, I mean, they have a mechanism to annotate data, but it's also useful to work with such data. So I have sent a link. This is one of the papers that they are presenting right now. But essentially, the idea is that there are a lot of data available for this particular problem. And we had, in the past, we had used some techniques, but not really concrete machine learning techniques. In those days, we were just doing pattern matching and pattern analysis and all that. And we used, in fact, if you see this, I can probably share my screen and show this specific page, I would say, because I myself don't know about this, but it's a quite interesting thing. So, do you see that? Yeah. So this is this is not a big deal in terms of what it does, but they have developed a tool which will essentially help to annotate some of these data which are not very well annotated. But these are different data set. Red is from the US. This is one of the first data that was released for this problem, the NILM problem, the non-intrusive load monitoring problem, NILM they call it. So as you say, it's like 2011, and it's a weekly electricity recordings. Several weeks of electricity recordings over a few houses in the US. And so, in fact, this. So what they have done is essentially they have several outlets from where they have picked the data, and so it's about trying and visualizing it. Perhaps I will try to visualize somewhere here. Apply. So I think we can download the entire. I used to work with red data in the past. So this is like, so you can zoom in different parts, and like this is only for one day, I guess, but you have the data where you have different things. So these people, what they have done is this tool that you have here is essentially to annotate it. So this data is already available. So they have an automatic labeling and annotation that they are trying to do. So you can do a lot of fixing to find which data, how to use, how to do this automatic labeling, etc. But we can probably take such data perhaps to work with. Perhaps, I don't know, just a second. I don't know, perhaps this data is not very big, in fact. So there is a low frequency data which we can actually download and use. So this is one option. Okay, this is one option. Okay, check. I don't remember the password. I have to write the password. So it will take some time to. I forgot the. I used to have this password long back. Anyway, doesn't matter. So we should be able to download it as well, I think, from here. But anyway, so this is one thing that we can do. Like we can export it to CSV and then download it, I guess. Yeah, so we should be able to download it. And so this is one option. But if if you're going to go in this direction, then it might take some time to explain what this problem is, how to go about doing it, etc. Maybe we'll probably have to wait for a week or something like that to tackle it. Or we can look at other options, because I can spend some time to explain it, though I haven't really prepared for it because it's been a while. So this is one thing. Or we can actually do something like take some simulator and then just simulate data and then work with that. That is one other way we can perhaps do it. So the link that you sent, what is it, Shiva?
Oh, that is Harish sent it. It's about, I think it's about the thing which he said, that is, if you have coordinates, can you kind of determine what it is that you're looking at, I think.
Yeah. Okay.
I still have to read the whole thing, but I think that's pretty much
That's
what
fine.
it is.
That's fine. We'll probably have to read it and then.
Yeah.
So I will just see then if there is anything else in Kaggle that we can, because I had looked at a few in the past and I'm not really I'm not remembering anything now. Yeah, so this is the Belkin disaggregation competition that happened 7 years ago, so it's quite a long time. And so this data is quite high frequency, and it focuses mostly on devices. I mean, it contains several devices, several types of devices, including laptops and other things, which are usually not really concern for people who do NIL LLM problem, because laptops and others don't really show up in the power signature in a significant way. They look like lamps or any others. So, but in this problem, it is useful because they have a high frequency data. They have a EMI data, which can be useful to work with consumer electronic appliances also, because those are the data that can actually be visible there. Otherwise, it's not visible in other, average power data that a smart meter measures. It won't show up.
Right.
Okay, so this is one really good data set. This is probably something we can look at as a few weeks long challenge.
Yeah, I have no problem with it. Can you have a look at that? Click on the data thing in the column. Let's see what it is.
Yep. So this is a 20 GB data. I'm sorry. So it's not 6 GB. Yeah, I remember that. We couldn't. We had troubles even downloading it at that time. Anyway, so it's it has, if I remember correctly, several houses. So they have, but I think it's totally 10 GB because they have both CSV and MAT files.
Mm-hmm.
So it's MATLAB files and are also directly available. So yeah, in fact, they developed everything because it's an academic work. They developed mostly in MATLAB, so you can use either MATLAB or Octave for this. But I think they now have CSV files, which we can use it with Python to work with. But one of the things perhaps that we will have to do is to see if we can work with this data without, let's say, I don't know if they have been okay, so CSV files are separate, I think, but it might have to even work with CSV files without decompressing them. I thought there's something like that. Do you know how to do that?
Without decompressing, there might be a unzip package in Python, though I'm not sure what advantage it would actually solve, because eventually it'll be the same data loaded in the memory, so it's pretty much the same thing.
No. It's not. So what happens is, I remember, this is again not me, but I was working with a guy who knew Python well, and he is a computer science guy, PhD, and there was another challenge we were working on. I don't remember now. It's with another competition, and there the idea was that he could essentially keep the zip file as zipped. He didn't really unzip it, but he could actually process the data in the zip format itself. So I don't really, or maybe it's a stream. So he was able to do the streaming without actually loading the entire data in the memory, because loading this data will be really, really difficult.
Okay. Yeah. Okay. No, that is quite possible. That is, even if it is not a zip file, you can always read your data in chunks.
Yeah, perhaps that's what he
So
did, yeah.
that you can do. So for example, if you, I don't know, For one, I don't know. We can start with this if you want, because it does seem like something promising.
So you I can launch a notebook from here. What do you think?
I guess you could. It's just that
Because
this
I'm
is
not
on
going to
Kaggle.
download this data.
You
I
can.
mean, yeah, I can.
I don't know. Is it that you have to download all of it, or is it just downloading bits of it?
I don't know. Maybe we'll have to see that.
Yeah, I think see the files, so you can actually just pick out what you want.
CSV. There are 5 CSV files, and okay, let me just look at the description of the file data. File contents. Okay. Okay, so there are so I think at least there are several houses, which means each house, H1, H2, we can probably download only one of them. That will be fine. And so which means we don't have to download a lot of them. Then just a second. So contents of the mat file is there. So perhaps we can try one of them. I will see if I can download this H1. H1.
Actually, H1 zip will contain everything. Maybe you can use the H1 CSV zip.
Yeah. Okay.
You see the difference in the size? Yeah.
Yeah, it's even bigger. I don't
know
which one has. So I think the H1 CSV is going to be bigger because it has the CSV data, whereas H1 is that MATLAB data.
I see.
Yeah, I don't think it's a good idea for us. Okay, so H2 H2 perhaps is smaller, yes, and H3 CSV it's even smaller, and then H4 is even smaller. So if I want to download, I'll download H4 because it's probably they have lesser amount of data.
So are these 4 different houses, or what is it?
I'm sorry?
Are these 4 different houses?
Yeah, they are 4 different houses.
Okay, then.
And I think we'll just download this one.
Yep.
I will see. What is it going to download? I'm just going to see. Yeah. So it's going to take some time. Okay, it should be done in a few minutes. So we can. You want to try to see if we can access the data by chunk? That we do right now.
Exactly.
Okay, just launch the. Okay, so what I'll do is I'll launch a new Python notebook.
How's the download coming?
Do you see it? Do you see the Jupyter notebook?
Yeah.
Okay. I think it's downloaded. I'm just going to go and grab it and put it in the same folder. This could be tough because, okay, just a second. I'll probably not have it in the same folder, but yeah, I will put it somewhere in the same, because this is in a cloud, it's shared in the cloud, so I don't want to
What is shared in the cloud?
So the projects that whatever folder that I put work with you, the folder where the Jupyter notebook is in the cloud. So if I put it in that, it's going to sync it and it's going to.
Yeah, you can put it in another directory. We can read that directory.
Yeah, exactly. Okay, so I think I know where it is, so it's we can work with that. That's not a problem.
Yeah. So this is a zip file. Yeah. So first you just have to look reading zip files in Python. Yeah. Anyone?
Okay. Let's see. Okay, let's start with the first one. Okay, just a second. I don't like people giving me cookies, so sorry about that. Okay, right.
Okay, zip file module. Okay, import zip file F. Now the problem is, okay, can you do zip file in your Jupyter notebook?
I will check if it is there. Yeah, I'll just check.
Very nice. Okay, so now if you do zip file and just do dot, actually you can import zip file actually rather than doing this, import zip file as Z or something like that, ZP or something.
Yeah.
That'll make your life easier.
Yeah.
Okay, now let's look at, is there something in chunks? IO. Okay, I think you need Google again. Go over to this thing, another Google thing, and just so you can scroll through this.
This one you see.
That'll open the whole thing. That's the problem.
Yeah. No, this one itself, you see that this one is just a file opener, and so we'll have to see how it can do it in a chunk. So even here, I think it doesn't open completely.
No, usually, I know, for example, in Python, you can do, if you do a read, and there is another one which is read, I think, read bytes or something of that. So that's the thing. So if you look, so you see Python zip file, basically, and zip file, and this should be one continuous so that it knows that zip file should be continuous. Basically, we're using the package. Yeah, and then say reading chunks. Let's hope there's a Stack Overflow. Yes, that is good. Okay, very nice.
Unzip by chunk to avoid consuming too much memory. Yeah, so I tried to use zip file. Okay.
So zip file is more or less creating zip file does not read. Oh, is it? Oh, I see. It already does it. Okay, let's try it out.
Looks like it's already there. Okay. So when we open it, it's not opening the entire file. It's just going to. Okay, let's see. So I think it's zip file. Right?
Zip file, yeah. Now, in string, yeah. Okay.
Just a second. Right. Okay, so
if it doesn't come when you do tab, then it probably means it is not it. Where is it? In the same drive or is it another drive?
It's the same drive.
So you can, where are you? C drive or is it something else?
Okay, just a second. Built-in challenge. Okay, I'm sorry. I think it's another one. Okay, now, yeah, okay, that's fine. So there's one more step I have to go. So it is H4. Okay. So
you have to
we
assign
will
this
put it
to an
into some-
object, yeah.
Yeah. So H4 data, something like that.
Yeah.
Okay, this looks good. Okay,
So can you just, what is he doing?
okay, this one, right? This one.
No, actually, this is not it. You can just come down, see if there's another, yeah. Zip info, zip extract. I think we have to do, okay, can you check the other one? I think we have to do zip extract, the other one, the tech challenge one. So if you look here, it is
Just a second. Yeah,
they're doing read.
Yeah, I mean, if we read, because this one, I think we'll read it completely.
Okay, let's see what extract is in the Jupyter notebook, and let's see if there's a help.
Yeah. So it is extract, is it? Or
No,
H4 dot.
H4 dot.
Okay.
And if you open the bracket and just do Shift Tab. Okay, guys. So, extract a member from the archive to the current working directory using its full name. Member.
Okay.
Member,
so it's going to extract the. In this case, I think it's just a file.
So what it does is, I think, what it does? It says that since it's a zip archive, you can actually collect several files. Right? Now, in our case, how many files are actually in the zip archive? Is it possible for you to just go have a look at that? Maybe then we can specify the exact file.
Okay.
If you just click on it on your Windows Explorer, it will show you how many are there without actually extracting them.
Yeah, I'm not extra. So Explorer, I'm able to go and there are several folders again. Okay. So there is, there are 3, 6, 7, 8. So there are 6 folders. And what I can do is I'll just take a small piece or something like that, which contain a few hundred MBs, and then put it in a folder, zip folder, and then work with that, because that might be a little easier for us.
That's okay. I mean, first thing we need to do is just try to figure out this, because this itself is an interesting exercise, being able to read a zip file.
Yeah, that is what I'm saying. So for that, because right now I'm a little afraid of playing around because it's going to crash the PC. So if I just take one part of the data, and that might be a little easier, because they have separated into test and training data. I'm not able to show it because I'm only showing one part of it. But I think we should be able to get this, because this one, we'll just see. Let me see if I can just copy a part of it and then paste. Yeah, it's pasting separately, but I'll just zip it and then put it into this folder. That will be easier for us to work. It's going to max out my. If I just leave it, it will max out my my drive. But anyway, it doesn't matter. Okay, this is taking time because this itself is 1.6 GB because it had unzipped it. It's taking a bit of time.
Yeah, actually the problem is, it's like this. Even if you want to extract anyone out, you have to extract the entire zip file.
Yeah.
So if we can just pick out of this, so like for example, if in the extract, you know one folder, right? And within a folder, you know a file. You can specify that as a string here.
Yeah. So, okay. Yeah.
So what we can do is...
Okay. So I just found something that they have high frequency data, which is what is causing all this. So I'm going to just pick out the non-high frequency data, zip them, and then bring it to our folder. So it's going to be easier for us. So the non-high frequency data, the total of them is I think a few hundred MBs. So which means that's a bit easier to handle. It will be in a zip file. It will be a lot smaller. The high frequency data is the one which contains quite a lot of different this electromagnetic EMI interference data, which I think we don't need it at the moment. And we will try to see. We will do the processing with this non-high frequency data if at all we need to do it. So we'll be able to manage with that. So I just got it done. I'm just going to transfer it and then put it there back into the folder. So yeah. Okay, so what I'm going to do is I will just add z.zip file, and we have something now in this tag training.zip. Okay, so yeah, so I just want to see what is this object. Okay, it's a zip file. Okay. So yeah, you see it right now. So we should be able to work with it. It's not very big. It's a 230 MB file. So it should be fine to work with this.
Yeah, that sounds good. So you can try it out now with, I mean, you can try that extract and within that.
Yeah. Okay, let me just see what was there. Member. Okay, let me see what member is there, and then perhaps.
No, actually, member is like a file name. So it's like what it is that it means that this zip file will contain like a file, and you're extracting that one out.
Yeah. I see. So I just lf1l. I think I will just try that.
Terry has just joined. Okay, nice to know.
Hey guys, sorry to interrupt. Just wanted to check in to say hello and see how things going. But I see you guys are deep in it, so I don't want to disrupt your.
Yeah. So I don't know.
No, that's the thing. You need actually just what I would say is go to your file browser, just copy the name of that file and paste it here as a string.
Which file? Is the one of the files that are there inside? Is
exactly.
That what you mean?
Yeah, that's the one.
Okay. Just. Okay.
Nice. Okay. So just pass that to an object so that.
Okay. So.
Yeah.
What is this? It's just a path, I think.
I see. Interesting. So
because
now,
I don't know what is there.
No, there's
just it's just there's nothing there in that. So okay, let me just see what else extract can do.
So okay, so then it has actually given just the path. Okay, try it out. I mean, just try.
Extract a member from the archive to the current working directory using its full name. Maybe it has already extracted. Let me just see if it has extracted.
I think what now has to be done is we now have to read it. So it's just a normal reading a file.
Yeah.
So now, Okay.
I'm just checking. Yeah, what it has done is it has extracted that file into that current folder. So the working folder has this CSV file. So it is just extracting. So it's just doing an unzip of only extracting a single thing. So it's not really useful for us.
Okay. Anyway, I don't know if you want to try to open that CSV file and see what happens. If not, then we'll find a way to read it in chunks.
Yeah, so that's what I think we should do, because right now that's what it'll be interesting to read them in chunks.
Yeah. So what I would say is just go to the.
This part had some answer, right? This guy had some answer.
No, I don't know about this, because this is like zip and all that. I can tell you what to do if you want to just read a file. So basically that, for example, now you have this file, right? So you can just create a file object. So just whatever, just say df. You can just say df data or whatever. Is equal to, then here you have to say, is it open or f open? I think it's open. Just try open. Yeah. And in brackets, and then give this file name path. So you can just say h4 lfi whatever. Because, no, I mean, yeah, okay, that's in the file. Okay, try it out. So this will now open this object. Okay, so if you click, it's a file object, right?
Yeah.
Now we can use, if you go into now I think we need Google's help, so you can just open a tab. So you just say that Python reading file in chunks. Yeah, read large file in chunks. So this is like a fairly well-established problem. That's why people usually ask it. So if you see here, this is basically reading it line by line, right? Now, if you come to the rest, I think if you keep going, read.
No, there's not. No, these are not very good, I guess. No, there is no accepted answer for this.
Okay, just check again with back to the thing. Stack of reading in chunks.
Yeah, this one try. Yeah.
Reading the full file. This we already do. Yeah, keep going.
Okay, there's a memory tracker. That's fine. You have to read. You don't have to read it all. So Pandas has chunk.
Nice chunk size. So
okay,
great. Let's try that out.
Chunk size. Yeah. Okay. Perfect. I didn't know that. Okay.
Yeah, if it's a pandas thing, so first you have to import pandas.
So we'll say df chunk or something like that.
I think you'll have to import pandas first.
Yeah.
Import NumPy and pandas both. Yeah.
Okay. So we'll say df chunk 1 or something like that, and then say pd dot read csv. Read csv, and then we'll say lf this, comma chunk size.
Just do shift tab if necessary.
Chunk size is say 1000, whatever, and we'll see what happens. So it has done chunk 1. Okay, sorry. What is this? What is df underscore chunk 1? It's a text file read. Okay, it's something else. So it's not exactly a data frame.
See, let's go back and see what's happening in that.
What? Yeah. No, sorry. Here. Okay.
Oh, so you have to actually call it as a chunk. So
No. This one they use chunk here. So it's not really calling it. It's just that they are going by 1,000 of 1,000, and then what they are doing is using the value counts. So, I mean, you'll have to, I think it looks like you'll have to, I mean, it's strange. Do you know this object?
So what you can do is just do a dir and do the df chunk. So let's see what is there in that.
You mean dir like this?
Yeah, and yeah, that is usually a good way to find out. Yeah. So these are all the attributes that are there. So get chunk. Can you just call get chunk on that? Actually, leave this, open another one because then we lose it otherwise. So we can use another. Yeah.
Okay, perfect. Right.
Because we have several things here. So. And do shift tab, see what happens.
Size, yeah, so it should be fine if we don't give anything.
Yeah, so then again you'll have to, very nice. Okay, now we have something.
Yeah, so it's essentially now giving the 1,000, so essentially, yeah, it's giving us the 1,000 data. So I can probably do this. Yeah, it's able to do that. 5.
Interesting. Okay. So it starts at 1,000.
Yeah, this, I'm sorry?
It starts at 1,000.
Yeah, that's strange. Yeah.
Can you do a tail and see what happens? Is it 2,000?
Yeah. No, it's going up to 3,000.
Interesting.
So let me just see the size.
You can do an info and see. Yeah, you can pass this to a df actually, because now this is.
So
there are 5 columns.
I mean, entries.
Yeah.
But it's strange. Yeah. These are all objects. I think these are all these complex numbers, so they are an object type. Yeah, I don't know what they have in the data.
So if you see 1,000 entries, 3,000 to 3,999. I don't understand. And why are we getting this?
Yeah. Let me just see.
Can you just can you do that read CSV if you go up again and do shift tab? Let's check out what that chunk size is. So come down.
Wait. There is, okay, let's go down. It's a lot.
Chunk,
so we'll see there.
Did you see chunk size? No. Okay, keep going.
Can we do a search? Yeah, it's here.
Chunk size int.
Text file reader object for iteration. So it is only going to send a reader object. So it is not going to send an actual chunk. But then it's a.
Can you do a Google with that pandas read CSV chunk size? I'm just trying to figure out if there's some other way, because we don't have the head yet. Yeah, you can. Second one is good. Efficient pandas chunk size. Okay.
Yeah, this one or this one.
Second one, yeah.
So this one is also there, using chunk size in pandas.
Yeah. So we used pandas to pre-process, save it to smaller than the colleagues. Can you see what that is? Chunk? No. pd.read table df columns result chunk, and can you scroll? No. Can you come down? Okay. Chunk size. Yeah, the one below. The code below. Yeah. The chunk size is equal to size. And this is.
Yeah, so this size is something that they're going to keep on their own, I guess.
Yeah. chunk size should not be too small. If it is small, if you come down, see chunk. If it is too small, the I/O cost will be high to overcome the benefit.
Yeah. So for them, you see that chunk size was 100. Was memory it took was this much, but 200,000 chunk size they were able to run it down. So I think they were doing an analysis of when is the there is an improvement. So I think 10,000 would have been something that they would have decided to be good, something like that, 5 to 10,000, I guess. Because beyond that there is no real improvement that you get.
Okay, can you go back again and look at that get chunk? And in the get chunk, if you do a shift tab and see what actually is there inside it, so get chunk, does it take an argument?
It just asks for signs. There is nothing else. Size.
No docstring.
It's just you give the chunk size.
Mm-hmm.
If you don't give a chunk size, it's going to give you everything.
So it has given us everything, which is the chunk. Interesting.
So for instance, if I do 2, I guess, it's going to give me 2 data set points.
I see.
I think there is some strangeness with the indexing. So it's doing something strange. Because now when I gave 3, it says 4002, 4, 3 and 4. If I give 7, it starts with 4005. So
I think you know what is happening? I think what is happening is it's actually reading off a byte stream. So every time we call it is incrementing.
Yes.
So for example, if you give now 1000, try 2-3 times, and I think it will keep on incrementing.
Yeah, you're right.
So how do we rewind? Can you go back and check? In the DIR, the one which is the DIR.
Mm-hmm.
Just check out all the others.
Yeah. Oh God. Get close. Yeah.
So here we have make engine chunk size close engine F get chunk and rows. Can you scroll down a little because the first are attributes? Scroll down.
Yeah. No, there is nothing else. So this one.
So read original options. Can you check what options is? Delimited. No, this is more about how the CSV is mapped out. Now that one. Can you just do read? Let's see what read is. And again, shift tab.
There is no docstring again. So I think it's
actually here you can try. So supposing you say end read and 1000.
Yeah, it's also 220. Let's see. No, it's again reading from the same this thing.
Okay, so I think you know what has to be done. We have to then close it and restart it. I think we have to close the byte stream. So maybe you can just say, there is a close method I saw. Just check.
Yeah.
Close. So if we do that,
it's okay. And then would we again do the read?
Yeah, you can again do now get chunk or whatever. Or you can actually even read is okay.
Yeah. It's not, I think it's restarting the card. I think there is something wrong because we didn't open it, I guess. We have to read. I think this is closed. So we'll have to do this again, I guess.
Yeah, I guess so.
So I'll just do it again, just a second. So I'm going to do this read. Yeah, it starts with 0 now.
Yeah, nice. So that means we need actually with that open statement we kind of maxed out the memory. But now you can do a close and now open with 1000. But it's still, I think in that case they don't have column names. What I would have liked is column names to know what it is we're looking at.
Yeah. There is no column names. Yes, that's true. So they have probably explained it somewhere. I'll be allowed to see all that.
Oh, okay.
So, yeah.
Anyway, since we have a few minutes left, what I would suggest is that you can just say close again and read 1000 and assign this 1000 to something like df1 or something.
Okay. Okay. So this one will be 0 to 9,000, 999. Perfect.
Okay, so we now have complex numbers. So can you just take one of them? The problem, what the problem is? The first column is actually not the heading. We have to rename the columns.
Yeah. So I think we'll probably recall it, because there is something called there's a way to say that the first column is
no, what you have to do is you have to then specify the column name. So when you read, you have to specify that do not take the first row as the name of the column, but instead specify. So if you do Shift Tab, read CSV, you see header is infer. So what we have to say is we have to now say header will be something that we have to specify. So supposing you specify how many are there? 6 are there, I think, right?
Yeah, 6. Yeah.
So
I'll just say 0, 1, 2, 3, 4.
No, I'd say A, B, C, D, E, F, so that at least we have something.
Whatever. Yeah, exactly. Something like that. So I'll just close it again.
Mm-hmm.
So that it's not header. So it should be a list, right?
Yeah.
Okay. Nope.
Oh.
There's some problem. Okay, what is the problem? Header must be integer or list of integers.
Yeah, maybe just give me 0, 1, 2, 3 for that case.
Okay, so it should be okay. I mean, but how do we just
above in that header, in that just replace this with, you can even say list of range 5.
Okay.
Simple thing.
Okay. And we should be able to see them. Oh, no, there's something wrong.
No, the problem is different. You know what the problem? The problem is it is now taking. So you have to now specify 1 colon onwards.
Not the header. Let me just see. It's not the header, I think.
It is the header, because what it has done now, we have said the first 6 columns should be header. So what we have to say is the header is
equal to none.
None.
Or something like that.
Header is none, yeah.
Okay, I had, sorry, I'll close it. Then open it. Yeah, okay.
Yes, now that's good. Great.
Yeah, I have done this before. Okay, fine. Okay, that's good.
So what we can do is we can just plot it just before we leave. We can just plot this thing.
No, but it's in...
yeah, you can plot as an ABS, I think. So if you do...
Complex number, it's actually an object file, so we'll have to probably change all of them.
No, just take a look at what 0 of 0 is. So like you can just do like... Is it df1 or something else?
Yeah, df1. So it's an object.
Oh, okay. Yeah, I think this will...
So you probably have to convert them into...
Yeah, I'll have to take into actually a number, and then we'll have to take an absolute. Okay. Okay, I guess then that's it. We can't do more. Yeah. So
we will see if we have any other data set, because I've been quite busy this week. I couldn't find time to do that. We'll see if we can find a data set and see if something can be done on that. And or one thing that some other people suggest is just to generate data using how do we say, using simulation.
Yeah, that is an option. That is an option. Let me see. Let's see. I'm just thinking, let me also then search on Google and see if there's any engineering data anywhere.
Yeah. Because nobody, I mean, one place that we are likely to get data is in energy sector, and so that's one place we can get data. And I would see, because it's been a while, and I know a few other data that we had. I think there was supposed to be some data from PMUs, phasor measurement units in a circuit. I will check where it is, if at all it is available, because it's been a long time that I did something with that. So what will essentially be is something to do with how they're working, and maybe we can do something. But beyond that, I think we can perhaps try to generate data from models. So this is something we can do, because even the projects that I did with it made a lot of sense to generate data, because at the end of it we know how the underlying system works. So within a margin, we can easily add some noise and some other unknown behaviors, and we'll be able to generate data. But anyway, I will have to see that. Yeah.
Well, that's all right. Okay. So
Okay.
yeah, I guess we meet next week.
Yeah, let's see. Okay, and maybe Harish, if he has something, we can check that, or we can continue with this. Yeah, or we'll continue with this. Okay. Okay then.
Okay, then see you all next week. Thanks for coming. Bye bye.
Bye.